Hello everyone, welcome to this video. In this video we'll be learning about straight line and how we can represent it. So the first question here is, what is a straight line? So if you look carefully here, a straight line, if you see various objects, for example we are studying about some table here, right? So in table also you see we have so many straight lines with us, right? So the edges also marked straight line. This is also straight line. Actually they are not straight line, they are line segments. What is the difference between a straight line and line segment, straight line segment? The difference is that segment is just a portion of the whole line, correct? So if you have some very long line with you, if you cut out some portion of it, then you call that portion as a line segment, right? Now what is a straight line? It is one-dimensional figure without any curve, right? That is why the name straight, and which extends to infinity on both sides. So we can continue increasing it in the positive infinity direction and minus infinity direction, right? And we only have one dimension here, only the dimension of length is there and no width is there, correct? So that is why it is known as one dimensional, and without any curve it is straight in nature, right? So this is visually we can see straight lines in the in the surroundings, right? There are many straight lines present. So how do we express the straight line algebraically on paper? So using some symbols, using variables, constants, how we can express the straight line, because we wanted to make analysis of the straight lines, correct? So this is our aim. So here we have a way. We can do it either by taking 2 points on coordinate plane through which the line pass. So you this is your coordinate plane. You take 2 points on it, right? Such that line passes through these 2 points, right? Like this. Then these 2 points are enough to determine what is this line. And if you do not have 2 points, then in that case 1 point through which the line passes and its slope would be enough to tell us what is the equation of the line. We can express it algebraically on paper, right? So what is the slope? We have heard about this term for the first time. So what is the slope of a line? So you see, for slope of a line, I am taking 3 instances of straight line on coordinate plane. The first figure, the second figure, and the third figure. In the first figure you see the line goes like this, line L. In the second it is vertical, and in the third case it is like this, correct? Now in all the 3 cases we can see that taking this positive x-axis, this axis as the reference axis, right, we can calculate what is the angle made by this line with the positive x-axis in the anti-clockwise direction. What is this angle theta? Or this angle, for this line what is this complete angle theta, and for this line what is this complete angle theta? So you see we are starting from this reference line, positive x-axis only, and we are moving in the anti-clockwise direction in order to measure this angle. So this angle, for each different line we have a different angle, right? So this angle marks one property by which we can measure what is this line, right? It is a characteristic of a line. So you see this theta is of importance here. Why? Because this is the angle of inclination, and it tell you how is the line oriented, what is the direction of the line. Is it less slant, is it more slant, or like that, correct? So you see here, actually when the line is like this, we say it is not at all slant, right? Not at all inclined. So its slope would be 0. You'll see in a moment how. And if your line is like this, we say it is very slant, right? So even if when you go to some adventure or sea, you have the roads on plains, they are like this, straight roads, highways, right? So there you do not feel anything. The car or the vehicle moves very smoothly onto such roads, right? So here we do not have any inclination. However, when you go to some hilly area, you see the roads are like this. So here you see feel some pressure onto it, right? So you see this road has some angle here, and this angle is the angle of inclination on which this road is has been laid on, right? So we are defining this angle theta as the angle made by the line L with the positive direction of x-axis, and it is measured in anti-clockwise direction. So this angle theta lies between 0 and 180 degree, right? So we now define slope of a line using this angle theta. How much is the inclination? When you calculate tan theta of it, we call that to be the slope of a line, correct? This is known as the slope or the gradient of line L, correct? So what is the slope? M is tan theta, and theta should not be equal to 90 degree. Now this thing you should keep in mind, why we cannot skip this thing. It is because when we have a line parallel to y-axis in the second case, right, or it is lying on y-axis, the two cases can be there. Either it is the y-axis only, or in the second case it is some line which is parallel to y-axis, right? This is your line L. Then in that case the angle theta, the angle of inclination, would be 90 degree. Here also it would be 90 degree. Hence you see tan 90 degree is undefined. Hence your slope is also not defined here. Therefore the slope of any vertical line which is parallel to or either coinciding with y-axis, that is not defined. That is why we have took this condition. In the second case, we have a special case where your line is either lying on this x-axis or it is parallel to x-axis, right? In that case, it could either be above or below x-axis, right? In that case, what is the angle of inclination? The angle with this line only, it would be just 0 degree because we are not moving anywhere, right? So the angle here is either 0 degree or 180 degree. When it would be 180 degree, when the whole of this line is reverse, it is like this, right? Then it would be 180 degree. So in that case, if your angle is 0 degree or 180 degree, then M is 0 because tan 0 is 0 or tan 180 is 0. So in that case, the slope of line is 0. So for any horizontal line, the slope of line is 0. You should remember these two cases, right? And you should also remember this formula that slope of line is tan theta, correct? So therefore we can see an example here. So the slope of line making an angle of 60 degree with the positive direction of x-axis. So here angle is given to us as 60 degree. So slope would be calculating the tan of that given angle, which is 60 degree. So tan 60 degree we know is square root 3. Hence the slope of line is square root 3 in this particular case. So I hope you understood what is straight line and how we can express the slope of a line. Well, that is it for this video. Thank you.